Right, so here we're going to have a look at this formula here, which allows you to find the acute and the obtuse angles between two straight lines. So if you imagine that you have two straight lines, you can see here you've got this angle here, which is an acute angle, or this angle here is the same thing, and you have this angle and this angle here. These will be obtuse angles. So you can find an acute angle and then just subtract it from 180 degrees to give you the obtuse angle. So I'm going to do a couple of examples where we can use this formula. So let's take two lines, two straight lines. Let's say 2x plus y minus 6 equal to 0, and let's take 3x minus 2y plus 2 equal to 0. So these are two straight lines, and what I want to do is find the angles between these two lines. So in order to do this, if you look at the formula again here, what we've got is m1 and m2. These are the slopes of the lines. So what we've got to do is find the slopes of these two lines, and then just put them into the formula and work out our angles. So let's see. This is it. Both lines are in the form ax plus by plus c equal to 0. So we can just read off the slopes here as minus a over b. So this is a, this is b here. Coefficient of the x is a, the coefficient of the y is b. So our slope here, we'll call it m1, is equal to minus a over b. In this case is going to be minus 2 over 1, or just simply minus 2. In this case, our m2 here, our second slope here, is going to be minus a over b, so it's going to be minus 3 over our b here, which is minus 2, so that will just give me minus over minus, which is plus, so it's just 3 over 2. So now I have our m1s and m2s here, so I can just stick these into the formula to work out our angles. So let me just write the formula down again. So we've got tan of our angle is going to be plus or minus m1 minus m2 all over 1 plus m1 times m2. So let's put these into our formula then. So m1 is minus 2, and then we've got minus 3 over 2 all over 1 plus or minus 2 times 3 over 2. Okay, so let's just work this out. So we have our tan theta. Tan theta here is just going to be plus or minus. This is minus 2 minus 1.5, that's minus 3 over 2, so that's just going to be minus 7 over 2, I think, isn't it? 2, 3, yeah. And then on the bottom here we have 1 minus, minus times plus minus, so this will just give me 1 minus 3. 1 minus 3 here. Okay, so this will just give me minus 7 over 2, so it's plus minus 7 over 2 all over minus 2. So this is just going to be plus or minus minus 7 over 4. 7 over 4. Okay, so if we just get the tan inverse then of 7 over 4, we will just get 60.25 degrees. So this is our acute angle. This is the acute angle between these two lines. If we want to work out the obtuse angle, then we just simply take 180 degrees minus 60.25 degrees, and that will give me 119.75 degrees. So these are our two angles between the two lines. Okay, let's just take another example. So what I'm going to do now is look at finding the equation of two lines. Finding the equation of two lines that pass through 0, 0. So two lines pass through the origin, and they make an angle of 45 degrees. So they make an angle, so we'll say theta is 45 degrees. They make an angle of 45 degrees with the line 6x minus y is equal to 9. So we want to find the equation of the lines that pass through 0, 0, and both lines make an angle of 45 degrees with this line here. So our two lines, maybe they'll look like this, and our 6x minus y will probably look something like this. So we got a 45 degrees here, 45 degrees here, and this point here will be 0, 0. So it would be something like this. Okay, and we want to find the equation of these two lines here. Now, in order to find the equations, we need a point on both lines, which we have, and we also need a slope. Because remember, the equation of a line is y minus y1 is equal to m into x minus x1. So in order to complete this formula here, we need a point on the line. We have that 0, 0, so that's fine. The only thing we don't have is the slope. We don't have the slope of these two lines. So let's we got to work out the slope, and happily enough, our formula for the angle between two lines is actually involves slopes, so that's fine. And we have the angle, we have our equation, so we can work out the slope. So let's take, this is one of our lines, this is our line here, and we know that we have an angle of 45 degrees between this and, in fact, both of our lines. Now if we look at this equation here, this is, if we put it, doesn't really matter, but we can put it in the form ax plus by plus c equal to 0. We can see here then that our slope, let's call it m1, is going to be minus a over b, so it's going to be minus 6 over minus 1. This is our a, so it's minus 6 over our b here, the coefficient of the y, which is minus 1. So our slope here is just 6, our m1 is 6, so that's one of our slopes. What we've got to do, so this is the slope of this line, so now we've got to find the slope of, let's say, this line here. Okay, so let's just write our formula down for the angle between two lines. So we know that the tan of theta, I'll just write it down first, is equal to plus or minus m1 minus m2 all over 1 plus m1 times m2. Let's just fill in what we've got here. So we know that our angle is 45 degrees, so we've got the tan of 45 degrees is going to be equal to plus or minus, now m1 we said here is 6, so we're going to take 6 minus m2, we don't know the slope of this line here, let's say. That's going to be over 1 plus 6 times m2. Now we have everything in this equation here except for m2, so we can find the slope of our other line or lines. So let's see, we'll actually get two slopes here because remember we have a plus and a minus here. So tan of 45, let me just move down a little bit. So we know the tan of 45 is 1, so that's going to be equal to plus or minus 6 minus m2 all over 1 plus 6m2. Okay, so let me just split this up and we'll work it out. So let's see, that means multiply across by 1 plus 6m2. So really you've got 1 plus 6m2 is going to be equal to plus 6 minus m1, and 1 plus 6m2 is going to be equal to minus 6 minus m2. So I've just split this up here and multiplied across by 1 plus 6m2 as well. So if I work both of those out, let me see, what do I get? Let's see, I have we'll have an m1 here, add m1 to both sides, that will give me sorry, that should be m2, excuse me, that should be m2 here, add m2 to both sides, that will give me 7m2 on the left hand side, subtract 1 from here, subtract 1 from this side, that will give me 5, so that will give me m2 is equal to 5 over 7. We've also got on this side, let me see, we end up with 1 plus 6 m2 is equal to minus 6 plus m2. Let me see, I can subtract m2 from both sides, that will give me 5 m2 on the left hand side. On the right hand side, subtract 1, that will give me minus 7 on this side, so that will give me m2 is equal to minus 7 over 5. So now I have two slopes. and those two slopes are the slopes of these two lines here. And remember, all I needed, this is the equation of my line. I have a point x1, y1, which happens to be 0, 0. I have a point on both of these lines, so that's fine. And now I've just worked out two different slopes for the two different lines. So I have everything I need to go into this equation here. So let's do that then. So we work out equation 1 and equation 2. So let's say equation 1 first of all. So we have y minus y1, which is 0, is equal to, I'll use this one first, m, which is 5 over 7, times x minus x1, which is also 0. Remember, the point on the line is 0, 0. So we end up with y is equal to 5 over 7x, or 7y is equal to 5x, or 5x minus 7y equal to 0. So this is this is our first equation. Let's look at the second one then, equation 2. We have y minus 0 again, and this time our slope is minus 7 over 5. I'm using this slope here now, yeah. So I use this one this first time. So minus 7 over 5 times x minus 0. Okay, so this gives me y is equal to minus 7 over 5x, multiply across by 5, that will give me 5y is equal to minus 7x, that will give me 7x plus 5y equal to 0. And these are our two equations of our two lines that pass through 0, 0 and make an angle of 45 degrees, with this red line here. Okay, so that's it. Just two examples there of how you can use this equation, this formula for the angle between two lines.